Welcome back. Let's do this thing. So now we are going to use the law of sines to find C. So the angle opposite C is 29.3 degrees. So C over sine of 29.3 degrees equals side length B over sine of this angle, which we figured out a minute ago was 117.1 degrees. So 85.5 over sine of 117.1 degrees. Then to solve for C, we're just going to multiply both sides by sine of 29.3. So 85.5 times the sine of 29.3 divided by the sine of 117.1, and we just grab a calculator, and 85.5 times the sine of 29.3 divided by the sine of 117.1. Now what did I forget to do? I forgot. Does it make sense? Okay, look, 96.4. Does it make sense for C to be 96.4? It doesn't, because the biggest angle is across from the longest side. So C has to be shorter than 85.5. So a light should go off and say, hey, something's weird over here. And what's weird is these are in degrees, and my calculator, since I had to open up a new version of it, started off in its default mode, which was radians. So I need to switch this guy to degrees. And now I can go back up and select that same calculation, and now it'll give me my answer in degrees. 47.0, and that is the dealio. Alright, so let's let V1 be 3, -5, and vector 2 is -2, -7. Simplify the linear combination below into a single vector. So, a constant, or a scalar, times a vector. All you do is basically kind of distribute that scalar through to each component of the vector. So 2 times 3 is 6, 2 times -5 is -10, 4 times -2 is -8, 4 times 7 is 28, and now we add the like components. So 6 and -8 is -2, and -10 plus 28 is 18. So my single vector is -2, 18. Alright, so now our vector is 4.7, -8.3. And we want to find not the absolute value, but we call that the magnitude of the vector. And the magnitude of a vector is a variation, and it's derived from the distance formula. So it's just the square root of x value squared plus y value squared. So the magnitude of V is the square root of 4.7 squared plus -8.3 squared. And I can have my calculator help me out here too. Square root of 4.7 squared plus -8.3 squared equals 9.538. So that rounds to 9.5. Alright, let's find the dot product of the vectors. So the dot product of two vectors is the product of their x values plus the product of their y values. So, and it's a scalar. So the v1 dot v2 is 6 times negative 5 plus negative 3 times negative 4. 6 times negative 5 is negative 30. Negative 3 times negative 4 is positive 12. So negative 30 plus 12 is negative 18. What is the scalar projection of V onto W? So scalar projection is the dot product divided by the magnitude of the guy you're projecting onto. So the dot product is 4 times 7, 28 plus negative 2 times 3, that's negative 6, divided by the magnitude of the vector that you're projecting onto. We're projecting onto W, so we want to get the magnitude of W, and that's the square root of 7 squared plus 3 squared. 28 minus 6 is 22. Square root of 49 plus 9, that's the square root of 58. So 22 over square root of 58, and all of our answers are in decimals, so we can throw this in our calculator. 22 divided by square root of 58 is 2.8887, which would round to 2.89. Okay, so same vectors. Now, what's the vector projection? What is the vector projection? Well, the vector projection is it's the scalar projection times, oh, it's almost the scalar projection, right? It's squared down here. So we did, before we did, we had 22 on top, right? The dot product was 22. 4 times 7 was 28. Negative 2 times 3 was negative 6. So the dot product was 22 on top. And then we did the magnitude. Magnitude of W was the square root of 7 squared plus 3 squared, which was the square root of 58. But if we're going to square that, that's just 58. And then we multiply that by, that's our scalar, we're going to multiply that by vector 2, which is W here, so times 7, 3. And then what, does this simplify? I sure hope it does, because this looks like a pretty sweet answer. If I divide by 2, I get 11. If I divide by 2 here, I get 29. So that, my friends, is the vector projection of V onto W. Alright, so is V perpendicular to W? And you might remember that two vectors are perpendicular or orthogonal if and only if their dot product is 0. So we need to find their dot product. So their dot product is 15. So let's see, V dot W equals, these are bold because they're vectors, 15 times 14 plus 6 times negative 35. So 15 times 14 is not that way, is it that? 15 times 14, my finger hit too many keys. 15 times 14 is 210. Plus, and this is going to end up being negative, right? Positive times a negative is negative. 6 times 35 is 210. So negative 210 equals 0. So the dot product is 0, which means that they are perpendicular / aka orthogonal. So yes, dot product equals 0. Alright, what is the measure of the angle formed by the two vectors? Here's our formula. Cosine theta is dot product over product of magnitudes. So dot product, 12 times negative 8 plus negative 2 times 10 over, now we're going to do the product of their magnitudes. So square root of 12 squared plus negative 2 squared times the square root of negative 8 squared plus 10 squared. And this is cosine theta. Cosine of theta equals that. So 12 times negative 8. 12 times 8 is 96, so that's going to be negative 96. Plus negative 20, so that's minus 20. Divided by the square root of, let's see, 12 squared is 144, plus negative 2 squared is 4, so that's the square root of 148, times the square root of 64 plus 100. So cosine of theta is equal to negative 106 over square root of 148 times 164. And I am going to say to you, theta is the inverse cosine of that. (148 times 164). Psych, it's negative 116. Anyway, now I'm going to throw this bad boy in my calculator. Inverse cosine of negative 116 divided by square root of 148 times 164. Ding. 138.1. We're in degree mode, so boom. 138.1. Ding. Well, I sure hope you had as much fun as I did, because that was a real hoot. See you later.